So if you want to find the speed, the unit for the rate constant, the unit of the rate constant, it vary from question to question, or unit of a k. Unit of k is not fixed. It depends on which equation is given to you. Example, say nitrogen is reacting with hydrogen, and it is forming ammonia. The reaction normally is reversible reaction. Just to explain the idea, I use irreversible reaction. So if I want the rate equation, so rate equation, according to this rate equation, rate denoted by small r is equals to constant time concentration of a reactant. So here nitrogen is there, and concentration of hydrogen raised to power 3. Sorry. What it shows here, the power of the concentration shows the order. The sum shows the total order, but the power shows the order. So this shows this is first order with respect to nitrogen, and it is third order with respect to hydrogen. What is the meaning? Like, what is the concept of first order or a third order? So first order and third order, what is the meaning? Like example, rate is proportional to nitrogen concentration. So if I double the concentration of nitrogen, and it is a first order, so if I double the concentration, the speed or the rate of the reaction will also be double. If I triple the concentration of nitrogen, the rate will be 3 times. So this is a concept that it is a first order with respect to nitrogen. And what about hydrogen? It is third order with respect to hydrogen. So how we explain this statement, third order with respect to hydrogen? So if I double the concentration, if I double the amount of hydrogen, so what happened to rate? Rate will increase by 2 raised to power 3. So 2 raised to power 3 is 8. So rate will increase by 8. If I triple the concentration, so what does it mean? It means the rate, because we make a concentration 3 times. So rate will be 3 raised to power 3, which is equals to 27. So rate will increase by 27 times. So this is third order with respect to hydrogen and first order with respect to nitrogen. And what is the total order of the reaction? The total order of a reaction is the sum of their powers for each concentration of each reactant. So 1 plus 3, that is giving 4. Is it clear, the concept of the first order and third order in this example? Any doubt in this? And the unit of the rate, so how you can find the unit of this rate constant? Okay, so we have the rate. If we write the rate equation, so the rate equation, rate is equals to K times the concentration of nitrogen and concentration of hydrogen raised to power 3. Now we need unit of K. So what is the unit of rate? Rate is mole per dm cube per second. So mole divided by dm cube and per second. So when you solve this, like if it was mole per dm cube divided by second, so I can also write as mole by dm cube second. So mole by dm cube second. K we don't know. What is the unit of concentration? Unit of concentration is mole per dm cube. That's a for unit for nitrogen concentration, and for hydrogen concentration, the unit is mole per dm cube, but that is raised to power 3. So what happened? This mole per dm cube will cancel with the mole per dm cube other side. And so it is 1 over second. When I simplify 1 over second and K, and this 3 power 3 is multiplied with mole also, and this power 3 multiplied with dm cube as well. So this will become mole cube dm cube. So 3 multiplied by 3, that's equal to 9. So dm cube 9. And we need K. So dm cube will be multiplied, mole will be divided. So this will be dm cube. Sorry, not dm cube, dm raised to power 9, mole raised to power 3, and second. That's a unit of K. If I want to write all of them in numerator, so denominator power should be used as a negative. So it is dm cube raised to power 9, mole minus 3, second minus 1. Is it clear? The unit of the K. So basically the unit of the K is not constant or fixed. It depends on the type of the reaction and the equation which shows or represent a balance, a complete chemical reaction. Now if we sketch a graph, for order of the reaction, first order, second order, zero order. Zero order means that if you change the concentration, the rate of the reaction will not change. First order means if you double concentration, rate will be double. So if we have a graph between rate and concentration, or for a zero order, that we double the concentration, the rate will remain same. Like if I say originally I was having say rate was 2 and concentration. So if we double the concentration, rate, there will be no change. If we triple the concentration, for rate, there is no change. It will remain same. But if it is a first order, then rate and concentration, if I double the concentration, rate will be double. If I multiply the concentration by 4, rate will also be multiplied by 4. And if it was a second order, then the rate and concentration, if we double the rate, double the concentration, the rate will increase by 4. If we triple the concentration, rate will increase by 9. If we multiply the concentration by 5, the rate will increase by 25. So that is for the second order reaction. So when we sketch a graph for the rate and the initial rate and the concentrations here, a zero order, what you will observe, you will observe a horizontal line. So why there is horizontal line? Because any concentration I use, I will get the same rate. But if it's a first order, if I double the concentration, rate is double. If I triple the concentration, rate is also triple. So you can see it is a straight line with a constant slope. And if it is a second order reaction, double the concentration, means 4 times the rate, triple the concentration, 9 times the rate, but concentration is multiplied by 5, the rate will increase by 25. So we'll observe a drastic change in the rate or the speed of reaction as the concentration is increased. So this is a graph for concentration and rate graph. So to represent a reaction is a zero order. So we can say like A was a reactant here. So you can see rate is equals to K times concentration of A raised to power 0. Because anything raised to power 0 is 1, it shows that the reaction does not depend on presence of A. Here it raised to power 1, it means power 1 here refers to, like if I double the concentration of A, the rate will also be double. And square here refers, it's a second order with respect to A. So what I can do, if I double concentration, rate will be 4 times, triple concentration, rate will be 9 times. These are the shapes which we observe for concentration. But if I change the labels here, for example, if I'm plotting a graph for concentration square, as a second order reaction is there, if I'm plotting a graph for concentration square and initial rate, but in that case, so if it is concentration square, so in that case, we should have a straight line which is passing through for second order, because this is a concentration square. So what happens if I double A, the concentration will be 4 times, because I double A. If I double A concentration, because 2 square is 4, so concentration is 4 times. If concentration is 4 times, rate is also 4 times. Is it clear? So if the graph is there for concentration square and initial rate for a second order reaction, then it should be a straight line. Because if I double concentration, A square will be 4 times and initial rate will also be 4 times. So they increase with the same ratio, same proportion. That's why it will be a straight line. Any doubt in this? Any doubt? Next, we can also use a continuous rate data to identify the speed or the rate of a reaction. Example, you have a reactant. Reactants are in the beginning, the concentration is say 0.06. Then it becomes 0, the concentration is continuously changing. So using this, the concentration and time graph, you can also identify whether it is a first order, second order, or zero order. So if the graph is there between, this is a concentration time graph, concentration of a reactant versus time. And it is obvious in the beginning you will have more reactant, but with the passage of the time, the reactant decreases. So you can measure the half-life. Half-life means time taken by half of the reactant to form a product. So if it was 0.06, a half-life will be when 0.06 changes to 0.03. Then another half-life is 0.03 changes to 0.015. Another half-life 0.015 changes to 0.0075. So whenever I will find a time interval from change from one concentration to another, what I will observe, all these time intervals are same. So if these time intervals are same, if half-lives are same, this also shows that this reaction is a first order. So for a first order reaction, if you want to identify if that the reaction is first order from a concentration and time graph, so you can measure the half-life. If half-lives are constant, it means the rate of the reaction, and the reaction is first order with respect to that reaction. If it is a second order reaction, then second order reaction, because in the beginning it's much faster, rapid reaction is there, but with the passage of a time it decreases and eventually it will very slow. So that's why in the beginning you have a shorter half-life, but with the passage of the time half-life increases. And for a zero order reaction, the concentration and time, the slope, because concentration divided by time or change in concentration divided by time is actually refers to rate. So here concentration and time, when you sketch a graph, you'll find a constant change with respect to time. So it shows that the rate is constant or rate is not changing even though there is a change in concentration. Like you have in the beginning more reactant, but reactants are decreasing, but there is no change in rate. Rate is constant here. If rate is constant, rate does not is not affected by change in concentration or amount of reactant. It means it is zero order. The slope of concentration time graph represent the rate of the reaction. Is it clear? So zero order reaction, you will have always have a straight line with a constant slope. Why the slope is negative? Because it shows that the amount of the reactant will decrease, but rate at which the amount of reactant is changing does not depend on the presence of the or concentration of the reactants. Any doubt in this? The rate constant, as we discussed, like it can have different unit depending on the question. The rate constant unit, for example, if it's a zero order reaction, so rate is equals to K times the concentration of reactant raised to power 0. 0 raised to power anything, that's our first order instead. So in this case, the rate is equals to K. So what are the unit of the rate? That is same as the unit of K. But if it is a first order, so rate is equals to K times the concentration of reactant. So rate is mole per dm cube second, and concentration is mole per dm cube only. So this mole per dm cube cancel with mole per dm cube. You're left with second, 1 over second. So 1 over second or second inverse you can also say. So here, so when you work out the rate for different reactions, you can identify. So unit of K depends on the overall order of a reaction. The value of K is independent of concentration. If we change the concentration, the K will not change. It is constant at a fixed temperature, and it increases. The value of the K increases with temperature and it decreases with higher temperature, because faster rate, that's higher value of a K. This is just an example already I discussed with you. Then sometime not sometime, most of the time, the order which we predict, like example, if you have a chemical reaction and it forms a product, say A is reacting with 2B, and this result in a formation of a compound C. If I say write a rate expression, so rate expression is R is equals to K times the concentration of A and concentration of B raised to power 2. So this is first order with respect to A and it is second order with respect to B. And overall order is, the total order of the reaction is 1 plus 2, which is equal to 3. But it is not necessary that what is the equation shows that will be the actual order of a reaction. This is just a theory. Actual order of a reaction you can find by initial rate method. What is the initial rate method? Means experimentally you can find. So a simple concept of an initial rate method. So we take in the beginning, like example, we have A, we have B, and then we calculated the rate or the speed of a reaction, and calculating a rate having a different techniques. You can use a slope also, the change in concentration divided by time to calculate rate. Example, in the beginning we use 0.1 of mole per dm cube of A and 0.1 mole per dm cube of B, and the rate was example 10. I'm not writing the units, just the numbers to explain the idea. Now what we did, we doubled the concentration of A. We doubled the concentration of A, but what we observed, the rate remained 10. So if we change the concentration of A and rate is not changes or rate is not affected. So what it shows that this reaction is zero order with respect to A. According to equation, it should be first order, but practically it is zero order. Means it does not depend on the amount of A. And if we keep this 0.1 and we double the concentration of a B, so if we double the concentration of a B, rate is also doubled, it becomes 20. So what it shows, we double A, B, and rate is also doubled. So it shows it is first order with respect to B. So actual rate equation or rate expression should be A raised to power 0 and B raised to power 1. And this technique is known as initial rate method, which is accurate, which is exactly shows the right order of a chemical reaction with respect to each reactant. So initial rate methods are used to identify the rate expression or rate equation. Because from equation, it is not always true that you work out from equation and that will be the actual rate equation. No. If they ask, for example, in a question, write a rate equation according to equation given. So you will write, use your technique, use the same method and write according to the equation. But using an initial rate method is the practical one and which is the accurate one, finding the rate equation. Is it clear? Is it clear? So you can see here a table. You can see a table here. You have three reactants. So according to this equation, if I write the rate expression should be K times the concentration of A, concentration of B, and concentration of a C square. Sorry. So initially it was 0.1. Now what we did, we keep B and C constant and we double A. When we double A, what we observe, the rate is also double. So what it shows, so rate is equals to K times, with respect to A, it is first order. Then this we make 0.1, we double this one. But which two results we have to compare in which the other factors are same, like this. So we'll compare 1 and 3. And the rate, you can see for B it's double. If we double the concentration, what happened to rate? Rate become 4 times. So what is the order of this reaction with respect to B? If we double the concentration, rate increases by 4. So it shows it is second order with respect to B. And what about C? For C, we will compare experiment 1 with 4. Because there is no change in A, there is no change in B. So C, this is multiplied by 2, but the rate does not change. So it is 0 order with respect to C. So C raised to power 0. Anything raised to power 0 is 1. So you can write rate is equals to K. This is also acceptable. They accept this in exam when you write this rate expression. A raised to power B raised to square and C raised to 1, C raised to 0, or anything raised to power 0 is equals to 1. So actually, this is the actual order of the actual rate equation according to the experimental data. Is it clear? This example. Another example is there. So, but in this example, we are changing both of the reactants. So we have to identify overall. Look, first what happened? This is 0. For Y, we double. Rate is also double. So this shows it is first order with sorry, not Y, it is X. So if the X is double, rate is also double. So it shows the rate is first order with respect to X. Then now which one we should compare, because uh, in the experiment 3, X is also changing, Y is also changing. So what we can do, if X is double, the rate will be double. So means 0.3, double of 0.3. So due to change in X, the rate should be double. So that should be double of 0.3, it will be 0.6. And then that 0.6 become 2.4. So if 0.6 become 2.4, it means it increases by 4. So it means the change in concentration of the B, or double the concentration of a B, increases the rate by 4. So it shows that it is second order with respect to Y. So this is a final rate expression or rate equation. Is it clear, this example? Identifying the rate equation from the change in concentration. Then the relation between the temperature and the rate constant, they are directly, it's like if you double the temperature, rate constant will be double. It's an exponential change basically. And this exponential change is given by equation, Arrhenius equation, in which k is equals to a Arrhenius constant e raised to power minus ea over rt. How we can simplify this equation so that we can use in our calculation? This equation is called Arrhenius equation. So the graph between temperature and k, it will be a curve which shows exponential change in value of a k as the temperature changes. It involves a mathematical solution for this equation. You don't have to learn this solution. Just the final result is important. But to get the final answer, first I have to simplify this equation. So in mathematics, if we take ln both sides, so this will become ln k. What is the purpose? Why we take logarithm, natural log? The reason for taking a logarithm, if the values have a greater variation, like example, if I say plot a graph from these values 0.1, 0.002, 1000, 1 million. It's really difficult to have all these numbers on the same scale because too much variation is there. So when they have too much variation, instead of plotting the graph for the same value, we take logarithm, ln. So when we take a log, the difference will decrease between the numbers and it will be in the same scale, so you can plot a graph easily. So if we take ln both sides, so purpose of the log or ln is to reduce the variation between the numbers. So this will be ln a E minus E over RT. E is activation energy for reaction and RT. When you take ln, so this will become ln K. This will be ln A. Whenever two quantities are multiplied in logarithm, we write them in addition. So it is ln A plus ln E minus EA over RT. And log, anti-log and log are means anti-function, so they cancel out each other. So it will become ln K is equals to ln A minus EA over RT. If I further simplify this equation, just rearrange. So I can say minus EA over RT. Here R is the general gas constant plus ln A. Then if I compare with the equation of straight line, y is equals to mx plus c. So if on y-axis, if I plot ln k, on x-axis, I plot 1 over t. So what will be my gradient? My gradient will be minus EA over R. So this gradient we can find from the graph. R is a general gas constant. Using that value, multiply, you can get the activation energy for the any chemical reaction. So when you sketch a graph for ln k versus 1 over t, you will find a gradient. Your gradient will be minus E over R, or gradient multiplied by R or general gas constant. You can find the activation energy for any chemical reaction. Is it clear, this graph? So if we plot a graph for ln k, and 1 over t. K is a rate constant. We can also plot ln k, ln rate as well. Is it clear, this graph? Because you compare with the equation of straight line, y is equals to mx plus c. So y-axis ln k, x-axis 1 over T. So your gradient will be minus CA over R. So in exam, you will have the values, and using those values, you have to plot a graph, and after plotting a graph, you will find the activation energy. Then a rate may involve, like if a chemical reaction may involve multiple steps by which the reactant form a product. So always the slow step is refers to a rate determining step. And we always write the rate expression in terms of the slow step. Because slow step will, if any reaction proceed in multiple ways or multiple stages or steps, then the reaction which is a slower reaction, which we will always use for a rate determining step. So example, the overall equation A plus 2B plus C gives D plus E. But the steps mechanism is when A reacted with B, it formed X plus D. Then X reacted with C, it formed Y. And then Y reacted with B, another B, it formed E. And first reaction is a slow reaction. The remaining two are the fast reaction. So which reaction is a rate determining step? The one which is the slowest. So this is the rate determining step. So when we write the rate expression from the equation, we will always use the slowest one. So this is first order with respect to A, first order with respect to B, and zero order with respect to C. So overall equation might be different, but the rate expression may involve different reagent. Same thing, another reaction means the same equation, but another example. The first reaction was fast, then slow, and then fast. So what is the order of this reaction? So rate determining step is a slow or the second step. So with respect to slow step, if I write the rate equation, if I write the rate equation, so it is rate is equals to K times concentration of X and concentration of C. And what is X? How X is formed? X is formed by mixing of A and B. So that's why A, B, and C will be there. That's the final. So X is intermediate, not one of the reactant. So must be replaced by a substance that make up the intermediate in the previous step. Is it clear? So in a rate equation, the slowest step is a rate determining step, and we always write a rate expression or rate equation with respect to that form. Is it clear? Any doubt in this? So I'll end the session at this point. How to find rate equation? Rate equation is, or the steps will be given. The slow step is always used as a rate determining step. And using a slow step, you will find the rate equation. Because X is an intermediate which is formed by A and B, that's why X is replaced by A and B. So I will end the session at this point and share the recording with you.